Welcome back. For today, announcements first. You have a quiz today. You receive an announcement, hopefully, about it. So quiz open at the end of the lecture, and you have the full day. So it will close at midnight. The topics for the quiz, what we have reviewed this week, the previous week, mostly patterns and questions about principles of object-oriented programming. So questions that haven't been in the quizzes before. Probably some of those questions are going to look familiar because some of them were in your midterm. However, randomly, some of you know the questions because of the midterm, but not all of you. So questions about abstraction, encapsulation, concurrency, polymorphism, and questions about patterns. Those could be the main topics, not the only ones, but the main topics for your quiz. So as usual, about 10 questions and about 30 minutes, so 3 minutes per question. And you can use your material, your books, your references. They are open book. Good. Okay, moving forward. Previous lecture, we talk about the singleton. Hopefully you remember the class diagram and you are able to identify the three main elements in the singleton pattern. I am talking about constructor private. I am talking about the variable that is from the same type of the class. Two options. Option number one, you have the variable here as an attribute. Option number two, you can remove the variable, but then you represent the relationship as a reflection in the class, since the class has aggregation, an instance of the same class. So two options, the variable, the relationship, the constructor is private, and obviously you need a public method to get the instance. Those three elements, the core of the singleton pattern. If you remember in your exam, in your midterm, some of you have this question about a class. We give you a class, cat, dog, or factory, TV, whatever, and we ask you about transforming that class to a singleton. Obviously, in your exam, we are removing that question because we haven't covered the topic, so don't worry about it. I answered that question to some of you, but for the final, you can expect the same question, a class, random class, and the question, the activity to do is to transform that class to a singleton. Basically, we're going to asking you to make the constructor private, to add the variable and the public method. So database connection was one of the options. Yeah, so that one. So now you know what to do for the final. Review the diagram and the code. Always, 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 if you have something like this, doesn't matter which is the name of the class, but when you are asking for an instance, when you are able to call methods just like this without using the new, a singleton is involved. So like for a connection. Okay, we reviewed this before. Something that you can use here, the singleton, an example that I will advise you to try. What if you have this program with the observer and the decorator, this program in which you are drawing this random number, something that you do is to decorate with a shadow, something that you do is another decoration with all these yellow previous positions. What if you need to draw the average of the X and the Y's? One dot that represents the average, one dot that is always going to be only one, and that one in red color correspond to the average of all the values X and Y separate that have been generated by the class source. So I would like to have this extra class whatever name you want to use, the red dot. And from that class, I want to create one and only one object. So the class is going to be a singleton. And that object, what I want is this or this. It doesn't matter if I select to use the blue rectangle with decorations or not, the decoration with the shadows and the yellow things or nothing, but I want this red that is independent from the blue, and that one is always only one, and that will represent the average of the numbers. If I ask you to do that one as a singleton, what could we do? I am sure that you remember the scenario. I am sure that you remember this class source, the one that create the random numbers. Now I am asking you for a red dot class. I am asking you to make it a singleton. So probably used to use the relationship is going to be something like this. Do we need to access the data, the numbers? Do we need to know the numbers? Yes or no? Hopefully we are clear that, yeah, we need the numbers because we're going to calculate the average. What could be the best way to connect red dot with source? Well, before we connect source with the other guy doing the draws, the guy decorated using observer, can we connect a singleton with another class using observer? Can this class red dot be a singleton and also being observing source? Two patterns involving one class? Yes or no? Yeah. Obviously, what we do is something simple. We can make this one. This is already observable. The only thing that I need to do is my red dot to be an observer. It doesn't matter. The fact that it's a singleton do not create any conflict with the fact that I can inherit from observer or realization if you're using the Java API. This one is going to have the update method and other things. It's going to have data structures to store all the numbers. It's going to have methods to calculate the average. All the responsibilities that you want to add to the class, they are fine. There is nothing in the patterns that tell you that you cannot add things. The pattern gives you the guidelines to have the singleton, to have the observer. But everything else, the functionality of your class, is up to you. Now, they are going to be connected with observer and observable. The last thing, what do we need to do for drawing the red box? Hopefully, at this point, you can imagine that the only thing that you need to do, because it's going to be a singleton, is to use the name of the class to call the method getInstance or whatever name you use. You do not need to create an object. You need to call the getInstance with the name of the class. And then you can connect the call for a method in the object. For instance, you can call the method draw, just like everything else that we have done. This is the first time that we could be calling the method draw without creating an object from a particular panel or a particular class that inherited from panel. It's just a class. It's going to have a method draw. Without creating an object, I can call it. And I could pass as a parameter the G. Help me. This is the line that I need to draw this thing or this thing. In which class, in which method can I put that instruction? Let's start for the method. Inside of which method can I do this red dot, get instance, draw, and send as a parameter the G? Any particular method that we have in which we can put that instruction? We need to access G. I need to pass a parameter, the G. In which method do we have access to that variable G? That one is going to be available in a method right? And paint component methods for this particular problem, you have several. You have several classes with a paint component method. You have the paint component that is drawing this guy, this guy, this one. In any of them, you can call this instruction because you have a singleton. And for the singleton, you do not need to pass a parameter. You do not need to worry about how to access the object. It's there in the class. The only thing that you need is to have access to the class. Ask for the object, call the method. We do not need another paint component method. We do not need another graphical element, another panel. For the red one, a class, a singleton, observer for the data, so that class can do the calculations that we want. And this line, in order to do the draws, and we can reuse any of the paint components that we have. Just call that one, and that paint component is going to be telling the singleton, draw another rectangle in a different color with whatever information you have. That in this case is going to be the average. Done. Hopefully makes sense. Hopefully you can practice with this. You do not have a programming assignment yet this week. We're going to talk about that next week. But completing this, the singleton, the decoration, the observer, could be a good practice. So try to do it during the weekend. Any question about singleton? Nothing. Okay. So I am sharing with you some source code. You have access to this. We talked about some of these classes before. Take a look. These classes can help you to complete this problem. Just putting things together. Now, with that, what we have is source code for graphical user interfaces, source code for things that we can draw in Java. But the most important is implementation of observer, decorator, and singleton. We can use those three in an application. But still, it's just one pattern per category. At least now we can understand what the categories are about, why this creation of object. There are several different ways in which we can create objects. One that we review is, I want only one object from that particular class. The structure, okay, what we want is to connect things. Okay, decoration is one way to connect things, one thing inside of the other, the original object and put inside of boxes, decorate. Or the behavior, like observing, is a behavior. I am interested in something that is happening with other class, so I am going to observe that class, and therefore I am going to receive information about whatever is happening there. Usually that information about something happening there is related with the value for a particular variable. I am checking the value of a particular variable there because I am going to do something with those values. So one pattern per category. What about reviewing more? At least trying to create an idea of what else do we have in each category. So trying to review something else. What about one more in each category? One more, something that I want to share with you quickly is factory, another way to create objects. We review the singleton. Now let's talk about a factory. And if you think about it, singleton, one and only one. Factory, I want a lot. Factory, like a product line. I want objects, a lot of objects. And all of those are going to come from the same place. Very good question in the chat. It's like, could we put together these two? Singleton make good factories? In fact, those two sometimes are put together. If we are going to create a class, and that class is going to be a factory, and therefore that class is the one that is going to create a particular product, a particular object, something that is a common practice is to make the factory a singleton. What? Yeah, you're going to have a class. The class is a factory. That class is going to be a singleton. Therefore, you can create only one object factory. You can have only one factory in your system. But that one is a factory because that one is going to create several objects, not from this class factory, but from a different class. It's a factory of something else. It's a factory of products. But the factory itself, we can limit to have only one factory in the full system. So make the factory a singleton. Common thing to happen. We're going to review an example. So singleton and factory. The other thing is in the structure, adapter. And hopefully you can figure out quickly, like adapter. Yeah. Think about you have a class here, another class here, and you want to connect them. Connect them. The only thing that we do when we connect classes is calling a method or creating a variable, right? There is no other thing, attributes or methods. What if I want to call a method here, but these two are not compatible, These guys do not have all the parameters that I need. Well, I can put something in the middle, an adapter. This class that I put in the middle is going to receive the call here, is going to do something, and then it's going to send the request to the class that I want to really contact from the beginning. Connect these two, something is missing, something is needed, values, parameters, names of methods, we're going to talk about it. Something in the middle, adaptation, adapting the connection between the two original ones. Chain of responsibility, behaviors. The idea with the chain of responsibility, kind of easy. You have two classes, student, professor. A student send a request to professor. The request, again, call a method, ask for something. The student is going to send an appeal to the professor, a request to review my grade, a request to provide feedback. Use a request. You are waiting for an answer from this class. But what if this class, instead of do the work in order to reply, this class have other classes, other objects that are going to help, like professor, student, using a request. You're going to receive a reply, but probably this guy, the professor, you know what? I am going to send the request, the one that I received, to the TA. And maybe the TA is going to send the request to the grader. And maybe the grader is going to reply to the TA, or at some point the TA to the professor. All these things here, you don't care about it. You send a request, you receive a reply. The organization in the back, the behavior about what to do with the request, the organization about sharing responsibilities in order to have several different classes accomplishing a goal. There is a pattern for that. Split the work in several objects from different classes. Chain of responsibility, behavior. Why behavior? Because one thing that I can do is observe others. That is a behavior. One thing that I can do is, if I receive a request for something, instead of working, sending that request to someone else. And that someone else is going to work for me. It's a behavior. So, factories, adapters, chain of responsibility. One more pattern in each category. I just describe quickly the ideas, the meaning of the name. The important part here is, well, do we have a class diagram for each of these ideas? And if we have a class diagram for each of these ideas, we also have source code connected with these ideas. That is the important thing, not just the description of the idea. Factory, yeah, factory, a place in which we're creating things, but how that is connected with my program in Java for something. That is the thing that we need to review. So, 3 patterns, the chain of responsibility. I describe you the idea. I am going to add this picture for you to remember, the factory and the adapter. And I am showing you the class diagrams for that. The class diagram for the chain of responsibility, the class diagram for the factory, the class diagram for the adapter. Do we understand the class diagrams? Now you have experience with association, composition, realization, inheritance. You have some expertise reading this. Hopefully they are clear. Moreover, if you look at these diagrams, they look familiar to maybe a diagram that you already know? Yes or no? Thank you. You notice that the first one looks like the decorator. In fact, it's the decorator without the childs that we usually draw below this class. But the important elements in the decorator, the inheritance, the parent that have 2 kids and one of them have a diamond, is there. Are you telling me that that is the class diagram for chain of responsibilities? Looks like the class diagram for the decorator. Yeah, they are very familiar, very similar. The implementation, the classes, the relationship, you are going to notice in the source code is very familiar, very similar. The concept, the idea is a little bit different. We're going to review it. What about the factory? Hopefully nothing new in the factory. The factories, well, hopefully you identify those 2, kind of the parents for 2 families. The parent of something called factory. Remember, it's a template, so the names do not represent anything. You are going to change the name for whatever you have in your programs. But we have this family of things that we are going to call factories, and we have this family of things that we're going to call products using the template. And then those families, they are going to be connected. Notice, we are not connecting the top of the family. That is going to happen in a different pattern. what we're connecting is somehow one child in one family is going to be connected somehow with one child in a different family. We are connecting one factory with one product. And the idea is this guy, the factory, is going to be creating the product. The class diagram is trivial. We are going to have obviously the main, and the main is going to be using the factory. And obviously the reason for that main to use the factory is because in some point that main want a product. The main can be connected with the parents. Polymorphically, those parents can be any of the members of the family, but that members, once I choose which is the member that I am going to be working with, that particular child in factory is connected with one particular child in the product, the connection down. Trivial. The adapter hopefully looks familiar also. At this point, you can be thinking like, well, I have this main. The main is going to be using a particular target. Target, you know, is kind of the representation of my goal, one of the elements that I want to connect. And that target want to be connected with this, the adaptee, the target, the adaptee. I want to connect these two guys, but for some reason they are not compatible. The solution, I described it before, this adapter that I am going to put here in order to make them match is one and only one class. One and only one. And the connections that we are going to use, the standard for connecting these two classes, one inheritance and one association. Inheritance and association. Can you help me? Why inheritance? Why the first thing that we do when we want to connect this thing with something else, the first thing that we do is to create a child. The first thing that we do is an specialization. Why? Rule programming. When you have a class, the recommendation is you do not modify the class. If that class has particular methods, particular variables, if that class is something that you do not create, is a library, is the work of a fellow programmer, whatever, the original one, you do not go and modify the source code of the original class. Always, always, always. You want to change the class, you want to add or remove something, use inheritance, create a child. In the child, you're going to have exactly the same as the parent, but you can do overreading, overriding, remove, delete, change to private, whatever. You modify your own version of the class. Copy paste of the class, inheritance. If you do copy paste, at the end, you're going to have two classes. And for someone else in the future, trying to understand the code, that someone else is going to need to read two classes. And if those two classes have similar methods, similar source code, you are not keeping the principle of dry. So I am going to modify the class, use inheritance. You are going to inherit everything. You're going to have everything without duplicating code. And in the child, by specialization, you can do whatever you want, the changes. For instance, change the parameters of a method. For instance, adding more variables, whatever. And the only thing that you do is by association, connect with the other class, with the other one that you want to connect. global ideas regarding how to move from the problem and the solution, the philosophical description, the draws, and what you're going to have in the class diagrams. Now, from the class diagrams to source code in a particular project, a different idea, right? Let's check. Chain of responsibility. Chain of responsibility, as we described, in 3 lines. Maybe you want to remember this for your exam. It's exactly the same thing that I described with all these pictures. The communication between the student and the professor having a full team of people, objects, working in order to provide an answer. We have this class diagram, the same class diagram that we use for the decorator. You understand this because you remember that this was the ball and this was the box. You remember that this is the guy that is alone, that cannot have anything inside. But then you can put this one inside of a box just because they have a common parent, just because the box have this diamond. You remember this. Moreover, you remember that you can continue doing the same, adding another box. You can have kids here. You can have different kind of boxes, or box and bags, whatever. But the idea was the original one, and inside. What if I told you that using the same idea, we can think about, well, this class here could be one class, the last element in a chain of responsibilities. That one could be something like the grader that I described before. And that grader is going to be the last element in a chain of responsibilities. That is the last element that is going to be contacted by someone. And what if this guy here, the one with the diamond, the one with subclasses, the box, is going to be someone else connected with this guy? And you know what? I can put someone else connected with this guy. Inside, connected. There is a difference between this idea of having things inside and this idea of having things connected. A ball inside of a box, inside of another box. A ball connected with a box, connected with another box. Which of these two are correct? Which of these two is really happening in programming when you create this decorator or this one? Do we really have objects inside of objects or not? Class A with a variable B inside. Do I really have B inside of A? Because that is the idea with the decorator, right? That is the idea that we described. We described this idea about, well, this is the ball. This is what I am calling B. And this is the box. This is what I am calling A. So B is inside of A. And the programming for that was something like this. This one class in the decorator. is really B inside of A, or is just B connected with A like this? In this point, you need to remember your programming skills. What is this? A reference, right? What happened really between objects doesn't matter which is the name of the class. The reality between objects is you never have inside of an object another object. That doesn't happen. The only thing that you can have inside of an object, really inside, is variables that are primitive data. When you have something like this, an object inside of the object, really, what you have is something like that. A reference inside of A to an object B. That is the reality. This is what happened. That is what happened for the decorator and for the chain of responsibilities. For the decorator, the visualization that we have is something like this, things inside, because we remember the widgets and the panels. That is what happened on the screen. But in the source code, what we have is the object widget with the object panel, and they are related. They are connected like here. It's just connections, always. My point with the pattern is, this is what we have. It doesn't matter that it's the decorator of chain of responsibilities. So obviously, this is a philosophical idea for the decorator. This is a philosophical idea for chain of responsibilities. Going back to the pattern, if they look similar, if they look like the same, what is the difference between decoration and chain of responsibilities? We are talking about the same kind of a structure. We are talking about the same connection between classes, and almost we are talking about the same classes. When we're going to talk about decoration, when we're going to talk about chain of responsibilities. Did you notice something in the class diagram here that is missing compared with decorator? Differences. Decorator and chain of responsibilities. We have the similar idea, similar goals. One difference. The goal of the decoration is to replace inheritance. The goal of the decoration is to add to the object or to the element that you are decorating two things: attributes and actions. You decorate something. You decorate an element, an object from a class, in order to add behaviors, more methods, or in order to add new values, new attributes. If you want to add to an object more data or more actions, the correct definition is we're going to decorate that object. Just like we have been done before using decorator pattern. I am going to decorate, that means I am going to add actions or values, or both. It doesn't matter. That is the meaning of I am going to decorate. Do you remember that something that we talk about is decoration is one way to replace inheritance? Instead of having this class that is going to inherit from one or for multiple classes, what we do is having this object and decorate with some elements here and some elements there. And this action of decorating is adding variables and methods from one class, variables and methods from the other. And then in this one, instead of taking those by inheritance, we add them by the process of decoration. That was decoration. What do you think about chain of responsibilities? In this example with the professor, the TA, and the grader, are we talking about attributes or is just about actions? And hopefully with the example, we can agree that in the chain of responsibilities, what we want to do is to split an action between several actors. What we want to do, even though the connections are the same, the idea is the same, most of the source code is going to be similar. When we talk about, I am going to apply a chain of responsibilities, it's all about the actions. It's all about methods. Again, I am going to have this class. This class is going to have connections with other classes. And the reason because we're going to have those connections is just like between the professor, the TA, and the grader. All of them take care of requests for appeals, review, feedback. All of them have that method. The difference is one of them is going to take care of a particular request, or is going to ask someone else to do it, or is going to ask someone else to do it. We are connected. But the only reason because we are connected is not because we need the variables or the method from others. We are connected. Only one of us is going to work. With the decoration. With the decoration, we have the connection. We have the connection, but this one is going to work. It's going to be draw. This one is going to work. It's going to be draw. And if we put more, all of them are going to work. When we talk about decoration, is all of them are going to do something. If there are actions involved, all of them are going to execute the actions. Moreover, that actions could include additional variables. All of them work, and they could have not only methods, but also variables, extra. When we're talking about a chain of responsibilities, we are connected. Only one of us is going to work. Only one. If you compare this with the decoration that we use for the graphical user interfaces, think about you have a panel inside of another panel inside of another panel with a widget, but instead of drawing all of them, when we talk about the chain, it's only one of them is going to be drawn because only one of them is going to run the action. Only one. We all can be called, but only one of us is going to execute everything, do the action, and then just go back. Only one rule. And the reason to have it is because only one is going to execute a particular action. Which one? That is a different story. That is a condition that we need to have. If you want to think about it, always, 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 if that is the decorator, if those are the systems that implement the decorator, the chain of responsibility is a very particular case of decoration, a very particular case in which we do not consider attributes and in which only one of the elements connected is going to run. And when you have this idea of decoration with only one of the elements that is participating, doing the action, and moreover, you limit the possibility of having attributes, in that moment, you change the name from this one to this one. It's a very particular case. Okay, hopefully the idea makes sense, but the source code. We already know the source code. For this one, you have it in previous slides. What about the source code for this one? Easy. This is the class with the main. This is the class with the main, and this one should be familiar. This paragraph looks like something that we have done before. Do you remember this idea of, well, what we have here is this H1, and we are adding inside something called H2, and we are adding inside something called H3. That is the description that we mentioned for the decoration, the connections, and the objects. Moreover, with the description of the pointers that we mentioned before, we know that really what we have is three objects. No one is inside of no one. They are just connected, like a linked list. So this, the same example, the same source code that you could imagine for the decorator, for this one. Now, what we do, that one. You remember for the decorator calling draw, you call a method in one object. Here, we're doing the same, calling a method in one object. Which one? The external one, like calling draw in the frame. Call the method, everything else is inside. Call the method, you are the first one in a chain. Nothing different for the main. They use exactly the same. Connecting things, calling one action in the external link. The difference, what we have inside. What we have inside. Number one, we have a parent. That parent have a method. And I am sure that you remember, yeah, it's just like the parent class that have this one method, and it was called operation for the decorator. So this is something that we knew. The common parent for everything, telling us which is going to be the name for the operation. Nothing new, good. Second one, what we have is the child that is kind of the ball or the guy that is going to be at the end of the line. The last one, the one that is not special, the one that is just a common trivial child from the class. One implementation, nothing special here. The special guy is going to be the other one. And it's a special one because it's where we are going to have the diamond, right? And you already know what to expect. It's going to be the class that have the inheritance. It's going to be the class that have the variable. The two connections that we reviewed before. If you have the variable, you need a method, the add or set, whatever name you use, the one that is going to receive the value and is going to put the value in the variable. Nothing new there. Override the method, override the action. This is the important one. Do you remember what we have in this method for the decorator? Do you remember the key ideas inside of the method operation? That was the name that we used before. Do you remember what we put there? One important thing in particular in the first line. one way to identify that we're working with decorator. Do you remember the first line? Do we remember that part? Do we remember that the first thing that we do inside of this particular method for the decorator is we need to call the parent, the super. We call the parent and we execute this method in the parent. Why? Because we receive the call and we want also the parent, the one that have more objects, to continue with the call. I am being called, but the first thing that I need to do is to guarantee that everyone is going to be called. So the first thing that I do is to call the next one, calling the next one using the parent, the common decorator. Did you notice that here we do not do that? It's not always that the call is going to happen. The signature for the chain of responsibilities is this condition here. Always, 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 if you are running a chain of responsibility, yes, you have this variable. Yes, you have this method to add a value to the variable. Yes, you're going to override a method, the method that you define in the interface. But the most important thing, inside of that method that you are overriding, you're going to have a condition. And that condition is going to define two possible paths. Two paths. Number one, this method is being called. I am receiving a request. Option number one, I take care of the request. I do something. Option number two, I pass the request to someone else. Only one of those things is going to happen, as you can notice. If I take care of the request, no one else is going to be called. If I do nothing, someone else is going to work. I'm thinking this example with this one be the class professor. I receive a request, I reply to you with an answer, or I forward to the TA. If I do something, here is the code that corresponds to the action of this class. If I do nothing, if I, for some reason, according with the condition, this request is not for me, I am going to call the same method, but in another object, the object that I have inside, the object that is connected with me. And you can imagine this H1 calling the method in H2, handler 1 calling handler 2, handler 1 is the professor, handler 2 is the TA. However, the TA is going to be another class, and that other class is going to be exactly the same that this one. It's going to be another class. It's going to be another object from the same class. And that other object is going to have a connection. It's going to have an add method, and it's going to override this method. And the only thing that is going to happen is the TA is going to take the same decision that the professor. Do something according with a condition that could be different, some parameters, some values, whatever. Or it's going to pass the request to someone else. To someone else, like this guy one. If you notice this one, the one that is here, the one that is not special, the one that is not connected with anyone, that one do not have the if else. That one is not going to take a decision. That one is receiving the request and do something or nothing, but cannot pass the request to anyone else. The last in the line. So the last in the line, like the source code for the ball, and the others, the ones that have a delegate that they can use, the variable become that delegate. The only thing that we have, the key signature for the chain of responsibilities, do something, or pass the message. That's it. Clear. Can you identify the difference between this code and the other? In your exam, can we ask you for creating a chain of responsibilities using a couple of classes? Hopefully, yes. Questions? Good. So, next one. We talk about the factory. I show you the diagram, I explain you the idea. Summary of the idea, something that maybe you want to remember. Again, could be something in your exams. For this idea, for the pattern, the class diagram, the only thing that we need to do, this class diagram is showing you obviously several factories and several products. That's fine. The key ideas is, number one, you need a common parent for your factories. Always, always, always. The parent for your factory is going to be an interface. The parent for your product is going to be an interface. In this example, the parent of my product, again, use an example to show you that the class do not need to have the name product. The class have a name according with whatever you are doing. The role is a product. In this case, I am talking about shapes, and they have the draw method. Okay, that is my product. Shapes with the draw method. I can use that interface to create different classes, and all these classes are going to have that method. And what they do in the method, I don't care, but they are my product. My product is this rectangle with this square, with the other rounded, whatever. Those are my products, and they are connected with a common parent. I need something similar for the factories. For the factories, a common parent used to have the possibility of using polymorphism. And then I can create my factories, the childs, the implementation of that. For the implementation, the only thing that I need to do, inheritance and override the method. How do I know that this is a factory? Because always, 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 a factory is going to have a method, and that method, the responsibility of the method is going to be execute the instruction new. New for what? For the products of the factory. In this scenario, I have this factory shape, and that factory shape is able to create two kinds of products. But there is no limitation about one factory creating only one product or different factories creating the same product. You can combine things as you want. The only thing is identify factories and products. In this example, I have my factory, and my factory is connected with two products, rectangles and squares. This one is a factory, and therefore have a common parent. These are products, and therefore they have common parents. In particular, according with the description, the line here is that dash dash. Implementation for the interface. Parent, parent, child. The connection between the childs, not between the parents. Something that you notice in the diagram, the last thing that I want to comment is, did you notice that the connection between the products, the factory and the product, any of them, is with a line that is not solid? It's not like this, but like this. Can you guess why? Why we move from a solid line between classes, association, and instead of that, we are connecting with a line that is different. What is different in this source code compared with source code that we have reviewed before? What is different between the connection of this shape factory and the connection of these objects. Any idea? Do you remember what is the meaning of this line? When we use that line? Silence. Ideas? Okay. So this line, having an object, a calling a method. Association, remember? Association, a local variable in which we call a method. In this example, you do not have the variable and call the method. Two things, the variable, call the method. If you have those two things, your line, solid, two things. This example, hopefully you notice, the factory is creating the product. So I am creating a local variable. I am using the object for something. I am calling a method that was the definition that we used before. And hopefully you notice, no. This is a case in which you have a class creating a variable, but it's not using the variable. It's just create the variable and return. But that return is not using. Using is calling a method in the variable, modify an attribute in the variable, working with the variable. What we have here is I create the variable and that's it. That is my only relationship with the other class. Create objects from the other class, but I am not going to use the objects. To represent that thing, is the arrow with the dashed line. Dependency. I am going to use the class. I am going to create objects. I am not going to use the objects. Association. I am using the objects from the other class. The relationship between factory and product is dependency. I am going to create the objects. The factory is going to create the product. The factory do not use the product. Do not call the methods in the product. Do not modify values in the product. Nothing. Use. I am going to create them. That's it. That is the factory. And that is the reason because you're going to have all this connection with the dot line. Factories and chain of responsibilities. We need to review adapter, and then we can put all the patterns together in some kind of project. But we need to do that in our next lecture. So at this point, any question, guys? No question. Okay, good. So everything is clear. Please review these two new patterns, the source code, the class diagram. Please be sure to understand the difference between decorator and chain of responsibilities. It's going to be an important topic in your exam and your next quiz. So review that. Any question, let us know, and see you next lecture. Thank you.